Hello IB, we're looking at the last section of this discrete binomial distribution probabilities, and in 23D part 3 we're looking at the mean and standard deviation. So what I suggest you do is get your calculator out. We're going to work with the calculator as well today, so if you don't have it with you, pause your video, go and get it, get organised. What we want to do is look at an example that we looked in the previous section where we had a coin being tossed. We've got heads or tails, and we've done it twice, so the experiment was repeated twice. In this scenario, what we're going to do is we're going to go through looking at it being repeated 15 times. So remember that notation that x is distributed in a binomial manner, so the random variable is a binomial, which means there's a success fail, and we're going to trial it 15 times. That's our n, and the probability of getting a success is 0.5. So that's like tossing a coin. Now we've got in your textbooks, if you can click on this application, which basically is like a tree that's been set up. So here we've got 2 rows, in other words 2 trials, and then we have little balls that come down out of here, and they can choose to either go to the right or to the left, which is like the probability of tossing a head or heads or tails. So we could go heads or tails, then the next option is heads or tails. So that's the path the ball can take. In our situation, we're going to have 200 balls. So we've got 2 trials, but we're going to do it 200 times to get our result. In fact, we're not going to go 200 times because we really want to see a strong result. So we're going to go 2,000 times, and we're going to make it happen fast. And let's have a look at what happens. So the little balls are coming down and going lots of times, and it's happening 2,000 times. We're repeating this experiment, so it's a repeat 2,000 times, but the number of times we're applying our probability is twice. So remember, with the previous example in our last video, we came out with the probabilities of a quarter, a half, and a quarter, because that's what we're doing. The ball can go this way, half a chance, that way, half a chance. So if we look back here, after 2,000 trials of this, we've almost got our quarter, a half, a quarter. So this percentage is telling us the amount of times it's landed in these 3 positions, and we've got that outcome. So that could be like 2 heads, 1 head, no heads. That's the actual numbers of the balls that landed, so they should add up to 2,000. In our story, oops, hold it, we want to go back smaller again. Oh, what's happened here? We'll shift that, and we're coming back this size. So in our example, I want to come back to this one. We want to have 15, we're going to have 15 options of applying that probability. So n is 15, and we will run 2,000 again, just so that we can get a good pattern happening. But we're now going to put this up to 15. So as you can see, let's see if we can make this a little bit bigger. Is it going to happen? No. All right, so let's get up to 15. Note here the numbers of these cells are increasing. So we want 15. Let's just make it large. And we're going to have it repeated 12,000 times going fast. Our probability is still 50%, so it's a 50% chance of going either way. If we've got 15 rows, then how many of these cells are along here? Question. Hopefully you come out with 16, because we'll have 0, 1, 2, 3, 4, up to 15. So that could be like no heads, 1 head, up to 15 heads. All right, so let's start this. Off it goes. And we can see the percentages are gradually increasing. The balls are moving very fast. And that's going to take a while for that to scroll all the way through, because we've got 2,000 balls running through that whole system. We can also look at this as a column graph. So we can see this is the amount that's landing in each of those scenarios from 0, 1, 2, etc. up to 15. So now that it's finished running through, we can see this as a percentage or frequency graph of what the distribution is like. So here's our distribution of probabilities. In this case, it's a frequency. We could turn that into a relative frequency or a percentage frequency. And we see we've got that whole range of values. Then we could say, well, what's the average result? What's the mean result? So it's about somewhere around here, our average result. We can also talk about standard deviation. So remember when we talked earlier about the spread of data? How far is the data spread? Is it all really clumped together, or is it spread out? And when we look in chapter 24, we're going to look again at the normal curve. We'll look at the normal curve in more detail and talk about means and standard deviations for normal data, for continuous data. But in this case, we've got discrete data. So in some ways, these columns shouldn't be joined together because it's not a continuous scale. We could either have 6 heads, 7 heads, 8 heads, etc. So our mean is here and we have a spread. If we change that in here, our graph is looking like, I'm just going to draw this in. So in this case, it was looking like we had some sort of data like this. All right, where this was up to 15. I'm just doing a continuous line graph showing the general shape as opposed to the columns, but it's discrete data still. So we've got discrete data. Well, let's have a now look, same scenario, but let's make the probability of success only 0.1. How will our distribution of all our columns, how's that all going to change when we only have 0.1? Tell you what we might even do, let's just capture this and then we can put that in somewhere. Also, let's put it into here. All right, good. Okay, let's now come back here. We're going to change our probability from 50% down to 0.1. All right, so there's about 0.1. All right, what do you think is going to happen? Same number of rows, all right? So we'll have the same number of rows, same number of times we're repeating it, but our probability of going, move the slider to alter the balls, moving to the right of each rod. So they're going to, instead here now, only go this side 1 in 10 times. So 1/10 of the time here, 9/10 to the left. So what do you think is going to happen? Have a think. Hopefully you'll think there'll be more down this way. So off it goes, and already we're seeing some down here, whereas in the previous example there weren't any. That was empty and this cell was empty. It's still empty up here, but now we're getting a whole lot more. Let's look at our column graph as it's growing. So we can see our distribution, because of the change in probability, has come all the way down here. We haven't got any landing out this end at all. So let's capture this one. All right, that's got the idea. We haven't got it all. So in this case now, we've got just a distribution that's all very much one-sided. I'll fix that up. All right, there we go. I've now got all that onto one page here so we can look at that more easily. So we saw none up here, all in the middle. So, and over this one I've now got that where our probability was 0.1. So we want to be able to talk about the average result, the mean or the expected value, and the standard deviation. Now remember, we can calculate the mean of a distribution or the mean of a result just simply by multiplying the number of trials by the probability. So that means for our example, we can just go, our mean is going to be, that's a mu, try again, is going to be the number of trials was 30 times our probability of 0.5. Oh, it wasn't 30, we did 15. 15 times 0.5. So it comes out at 7.5. So that is our average result. And if we look here on this scale, we can see there's our 8, that's a 7.5. We don't have values down here. We've got some, there's a bit up here, so it's not, we haven't done an infinite number of trials, but our mean comes out, our expected value is 7.5. Sorry about that. We can also calculate the standard deviation, and we can see the formula here, which a lot of you discovered in the trial but weren't able to use, because this is where we use this formula for the standard deviation in a binomial distribution. So the standard deviation sigma is going to be the square root of the number of trials, which is 15, and then times the probability of success, which was 0.5, times 1 minus that, which we also can see as 0.5, but I'll write it in to show you what we're doing here. And then calculate that in your calculator, and it comes out at 1.936, etc. So that tells us that the spread of the data is the average spread is 1.9 from that mean. Remember, that's your definition of a standard deviation, the average distance from the mean. The variance, remember, is the square of the standard deviation, so it's just not taking the square root. So those formulae you all need to be able to know and use. Certainly you could use some of that in a you could do in a non-calculator paper, a bit hard to take the square root. Now we can set this all up on your calculator as well, and so we can put our initial data in. If we come back to this one, what we want to do is find out what is the spread for all our different x values. In other words, calculate this. So on here, this is our x-axis. Up here is our, remember we had the formula for calculating the binomial, the actual value for the probability. So our rule up here was, where are we? Down here, somewhere we're getting closer. Is this is our rule to calculate the probability at a particular R value for our binomial distribution. So we want to put in here, it's our binomial distribution, the probability of x equal to our little different x values. So this is where you can go to your calculator, and we can do this on your calculator. So the first thing we want to do is list all the possible values that our x can be. So we want to list those. We're going to add a page. I've got a calculator page set up at the moment, and we're doing a list and spreadsheet. In here, let's call this the number of successes. So I'll just call it success. All right, we've always got to have something up the top there. And we're going to have in here our values 0, 1, etc. And then if you can highlight those and fill downwards. And we want to get down to 15, not that far. So we'll just get rid of some of these. Don't want these ones. All right, and we don't want 16 either. Let's just do our 15. So we're going from 0 to 15. In here, we want to find out what is the probability. Okay. Am I going too fast? If I'm going too fast, pause the video on this page. This is, if you always click in your textbook, it will show you on the calculator how to do all these. So this here explains what we're doing and how we're going to get to the graph. So pause it there so you can run through it at your pace. So our probability here is going to equal, we're going to do a calculation. If we go to menu, option 4 for statistics, we're working with statistics, and we want to look at distributions, number 2. All right, we don't want that one. Back again. So we want menu, 4 for statistics, 2 for distributions. Now we want to come down here and find our binomial PDF. All right, so we want the exact value. We're not doing a cumulative one. The number of trials is 15. Our probability of success is 0.5, or with 0.1 for the other case, but we'll do in the 0.5 one. So now when we enter, that fills in the values for the probability as a decimal, not as a percentage. So we can see that's all been filled in down to our 15. All right, not below. We can now look at a graph of that, which means we now go put a new page in, and we're wanting to see this one, which is our graph with our data and statistics. Down here we want to click on, that's the numbers of successes, and up here we have our numbers of probability. What is our actual probability? So again, this shows you the dots. It doesn't show you the column. We could set it up like that, but that shows you the distribution that we got, which matched what we found earlier. So you could set this up in your calculator. This is, you're not determining whether you try it 2,000 times or 20 times. You're just going, right, what would it be? What's the theoretical answer? If we come back onto here, we can calculate the mean of our distribution. All right, so if we want to get the mean of data, remember we're going to menu. We're looking at statistics, number 6. Stat calculations, we want to do that. We're not going to look at the distributions at the moment. We're looking at the stat calculations. Now, how many variables do we have? We basically have one variable, which is our number of heads, and a frequency. So it's one variable statistics. We've got one list of data, so that's okay. Our data list is going to be our success column. The frequency is going to be the probability. For example, we've got a mismatch. Let me check with that. Sorry. Okay, I found the problem is because I deleted those values and it's fixed it up. So what we're going to remember is statistics, stat calculations, one variable statistics. That's okay. We're doing our numbers of successes and then the probability. That's all right. So this is what we come out with. So we come out with our mean is 7.5. And our standard deviation, remember the sigma SX, sigma X, not the SX, is 1.936, etc. So we can get our stats for a distribution, for the overall distribution, by putting the data into the table. You don't need to see the graph, all right? It's just a nice to see and going there. So we come out with the same values. So we could do the same for the probability where it was only 0.1. So have a go at that, and we'll talk about that in class. So we've seen how to do it on the calculator and how to calculate it manually. We'll go through that in class as well. Let's just do one quick example here from the textbook. We got bolts by a machine that vary in quality. The probability that a given bolt is defective is 0.04. Random samples of 30 bolts are taken. If X is the number of defective bolts in a sample, find the mean and standard deviation of the distribution. So our mean, remember, let's go blue. Our mean is, you can just simply go, the number of bolts, number of trials was 30, and the probability was 0.04. So we come out with the average number of bolts that were, what's our defective, that's our random variable, will come out at 1.2. All right, I've just gone in and filled the rest there. So our standard deviation, remember, is n, number is 30 trials, or 30 bolts in this case, times the probability of success is 0.04, times 1 minus that, which would be 0.96. If you take 1 minus 0.04, and we come out with our standard deviation of 1.073, etc. Part B, y is the distribution of non-defective bolts. So this is now our random variable is now y. Find the mean and standard deviation of this distribution. So in this case, our mean is going to be 30, but it'll be times 0.96, which is 28.8. All right, so it's interesting, like it shouldn't surprise you that that is the complement of that. The average of this is 1.2, the average of that is 28.8. Anyway, the standard deviation is going to be the square root of 30 times the probability of non-defective is 0.96. Then 1 minus 0.96 is 0.04. And of course, that's going to come out the same value as we got up here, 1.073, etc. So if we're looking at the two different options, they will have the same spread, but just a different mean. So that mean, if we looked at a distribution, would be right up here with the same spread as this one, where the distribution is centered around 1.2, so that would be this way with the tail out that direction. So there's your 1.2. This distribution will be out at 28.8. So that's the average for that option. Same spread. They're the same. Okay, what we'll do in class is have a look at this example. This is one of the IB questions, number 3, that we'll look at when you get the sheets. And we'll also have a look at another one as well. So thanks for listening and looking forward to seeing you in class.